Welcome, everyone. Thank you for joining me for this presentation at our virtual OCP Global Summit. I'm David Wolf from the University of New Hampshire Interoperability Lab. I'm going to provide an update on what's happening with regard to compliance for OCP NIC 3.0 products. Here's a look at our abstract. While you take a look at it, I'll give a quick summary of my work at UNH-IOL, as well as that of my colleague Mike Klempa, who's been working very closely with the OCP NIC 3.0 subgroup. Of course, our primary work at UNH-IOL is compliance and interoperability testing, and we test many of the technologies that will be supported by the OCP NIC 3.0 form factor. I'm overseeing our activity here at the lab with respect to data center infrastructure, and my colleague Mike oversees our PCIe physical layer test services, a lot of emphasis on electrical signaling there, as well as our high-speed Ethernet test services. So it's natural that we would be tracking and supporting the work around OCP NIC 3.0. Here's our agenda for our presentation today. First, the OCP NIC 3.0 compliance program goals. What's the big picture that we're trying to accomplish? And then, why is compliance necessary? We're building on top of some well-known technologies. So why do we need to have this program? Next, we're going to talk about electrical testing, what that looks like, what's available today. And then we'll talk about some of the new test areas that get opened up because of the OCP NIC 3.0 form factor, management and mechanical, because these are two things that make that new form factor so useful. We'll talk about some next steps aside from those new test areas. And then, of course, we'll have our call to action, how you can get involved. So what are our goals for this program? Well, basically, we want to make sure stuff works together. When we plug it in, it should work. And we want to be able to prove that to the community, to the end user. In order to do that, we'll be providing collateral such as reports and an integrator's list for compliant products. And doing this is going to increase confidence in this new form factor for users and help drive adoption. Now, as part of this program, we want to make sure that the proof, the evidence, the collateral that we're providing is providing information that users find helpful when making a purchasing decision. Now, what does that mean? It means that when a user or an integrator plugs an OCP NIC 3.0 card into a system, they should be confident that it will function properly in that system, that it fits mechanically, that it will negotiate to the highest signaling speed, that all the PCIe lanes will come up, and that the product is identified and managed properly. If users are having to figure out those basic functions and debug those basic things because compliance didn't happen, adoption will suffer. And so we want to make sure that doesn't happen by having a robust compliance program. You see, when these basics are proven out by the compliance program, the user is able to focus on their own internal testing about the things they really care about: thermal behavior, performance under certain workloads, and things like that. That's what we want. We want to be able to provide a baseline for the user, a baseline expectation for how well things work. So why is this compliance necessary? Well, in a well-designed compliance program, the tests are a good predictor for interoperability, and this can make multi-sourcing much easier. Further, compliance, especially electrical, thermal, and mechanical compliance, is a good predictor for margin. Now, let's think about that. Many of these OCP NIC 3.0 products will be deployed in high volume. And naturally, anytime you have a large sample size of product, there may be manufacturing variations, both at the silicon level and at the mechanical package. Compliance testing, rigorous compliance testing, can help ensure that even marginal or borderline products will still be interoperable. If we don't do compliance testing, we risk that a nominal sample is out of compliance and that a marginal sample is not even interoperable. And this causes problems for the user and suppresses adoption. So we can see the need for compliance testing. Well, what about electrical testing? When we think about electrical testing for OCP NIC 3.0 form factor, a natural question is, well, why not just test this with PCI SIG? That SIG has done a great job over the years building a solid compliance program for PCIe. They've developed tools. There are lots of expertise out there for doing this. And spoiler alert, we want to reuse a lot of that for OCP NIC 3.0. But testing through PCI SIG is not a perfect solution in this case. The SIG has workshops where they do compliance testing to qualify products for the PCIe integrators list. Often those workshops are at capacity, they focus on certain form factors, and adding another product type to those workshops can be difficult. Further, sanctioned official testing outside of these workshops is not available. So if you want to get a product on the PCIe integrators list, you need to attend a workshop. And we think about the situation we're dealing with right now, that can be very difficult since workshops are canceled due to restrictions on large gatherings and travel. So enabling independent labs, like we're trying to do here with OCP NIC 3.0, can alleviate that. Also, the process for onboarding new tests and form factors in PCI SIG can be difficult. There's a great deal of rigor there, and there should be. That's what's allowed that PCI SIG program to be so thorough and well regarded over the years. Further, the PCI SIG program is focused on electrical and protocol testing. It doesn't address the management and thermal aspects of testing OCP NIC 3.0, which is so important to this form factor. So we really want to use what's best from that PCI SIG program on the electrical testing front, but also add on to it to really test everything we need to test with respect to OCP NIC 3.0. So what's happening for OCP NIC 3.0 electrical testing today? Well, first, in order to enable electrical testing on this new form factor, the OCP NIC subteam had to design and test some new test fixtures. And here they are. You can see some pictures of them, a compliance load board and a compliance base board. These have identical functionality to what you would see in the PCIe add-in card or AIC form factor, CLB and CBB, but in a different mechanical form factor. We've used these at UNH-IOL for testing and found that they're electrically identical to the regular PCI SIG, CLB, and CBB, and they work quite well for testing. These form factors, or these fixtures rather, are available today for folks who want to get this testing up and running in their own lab. One thing to note about these fixtures, they were originally designed for OCP NIC 3.0, but the actual connector they use is used in other specifications as well, such as for some of the new NVMe SSD form factors like E1.S and E1.L, or you might have heard of the ruler drive. So these fixtures can be used in those environments as well. Now, what exactly are we doing for this electrical testing at UNH-IOL? Again, we're following the PCI SIG procedures, just using a different form factor test fixture. So that includes return loss testing, jitter and eye diagram tests for both PCIe 3.0 and 4.0, protocol testing for PCIe 3.0 protocol using the Teledyne LaCroix system, and we'll also be using the LaCroix Z4 platform for the 4.0 protocol testing. There's not major changes from 3.0 to 4.0 protocol-wise, but there are some places in the specification where previously reserved bits are now in use. So if you have a 4.0 product, you want to make sure you run the 4.0 protocol tests on it, or you might get some unexpected protocol failures because of those differences in reserved bits. So just something to pay attention to. Now, as I mentioned, we've already done these tests here at UNH-IOL as a proof of concept on products from Intel and Mellanox, and that test service is available today. And we're going to have another presentation from UNH-IOL from some of our students. They're going to go into the details of that. Next, we'll be updating our capability to support PCIe 5.0 and 6.0. What about management testing? As we said at the outset, one of the big benefits of using OCP NIC 3.0 form factor is the ability to manage using NCSI. And in fact, on this front, we've already heard of a few interop issues around the timing of those NCSI signals. And so compliance testing there is going to be very important. Now, in addition to the NCSI management, OCP NIC 3.0 form factor includes SM bus pins for management as well. So we're going to see that some systems are using NCSI for management, others are using SM bus. Now, naturally, as we have more options for management, we're introducing the potential for more interop issues. So we'll be expanding our testing to include checks for management support, both on SM bus and NCSI. It's really important to get this right because the management is often done at the BMC level. And if a BMC is updated and there's a compliance issue with a NIC, now that NIC can't be managed. So we want to get ahead of that and include compliance checks for the management interfaces that OCP NIC 3.0 uses. Now, what might that look like? Well, first, testing the state machines for NCSI, checking different traffic types. And we're going to work with the OCP NIC 3.0 subgroup to work up a test plan there. And there's lots of experts in that group that are very familiar with this and very familiar with what the needs are. Now, in addition to management testing, we want to add mechanical testing. This is one of the key motivations for the OCP NIC 3.0 form factor, a form factor that enables cooler systems and better airflow. Now, this might seem like a straightforward thing, mechanical testing, but if you get it wrong, none of the other stuff matters. None of this works. If the mechanicals aren't working, the management and the electricals aren't going to work at all either. And I can tell you from experience testing other products that when the mechanical dimensions are out of spec, none of the other stuff matters. And we have seen cases in other technologies where products were out of spec mechanically. And so having testing for that was very valuable. So in order to address this in the OCP NIC 3.0 world, we're looking at adding checking of samples with go, no-go gauges to check for the proper dimensions. And again, we're going to work with the OCP NIC sub-team on that. What are other next steps? Well, first, launching our service for electrical testing on OCP NIC 3.0 products at UNH-IOL. As I mentioned before, we've already done a proof of concept there with a couple early partners just to test out the test. And as I mentioned, we'll have another presentation on that. Next, we'll launch an OCP NIC 3.0 integrators list, which will show what products have been successfully tested independently at UNH-IOL. This is going to be useful to buyers and integrators as a baseline for what products should be integrated into their design. We're also looking at a logo for tested products to be used in the OCP marketplace. And then, of course, further development of the management and mechanical tests to expand coverage of the OCP NIC 3.0 test program. So what can you do? How can you get involved? Well, first, if you're interested in implementing or using the OCP NIC 3.0 form factor, follow the activity of the OCP NIC 3.0 subgroup. There's a lot of activity there. And here's a link both to join the mailing list and also to get the 1.0 specification. Next, if you're actually doing validation of an OCP NIC 3.0 product in-house, reach out to us to get the necessary fixtures for the physical layer testing. And here's a link for that. So thanks again, everyone, for listening in. There's a lot of interest around this new form factor and a lot of interest in compliance validation of it. And we're excited to be involved in that here at UNH-IOL. I hope you found this useful and informative, and I hope you enjoy the rest of our virtual OCP Global Summit.